Hello, welcome back. Today's lesson is lesson 3-1. It's titled 88 miles per hour, and you will be learning about slope as a rate of change. Chapter 3 is an intensive study on all things dealing with lines and linear functions. So no more exponential growth, we're all linear at this point. This is on page 275 of your textbook. And they give us some examples of some rates of change, like the DeLorean in Back to the Future. That is a rate of change. We're going to define it for us in a moment. Under section 3.1, where it starts the classwork, they define a rate. A rate is just a ratio that compares two quantities. If any of you were out driving recently, you saw a rate, and I hope you obeyed the rate that was on the side of the road. If you got on the highway, you probably saw a sign that said 65 miles per hour. That's a rate. That tells you you're only allowed to drive 65 miles in 1 hour. The DeLorean had to go 88 miles in 1 hour, so that's the example he's using here. Speed is just one example of rate. There's other ones. If you're making $15 per hour, that's a rate. Medication can be administered at 5 milliliters per minute. That's a rate. Your savings account is growing by $50 per year. That's a rate. So these are all different rates that we may have. So sometimes things are increasing or decreasing, but we're going to be talking about ones that remain constant throughout chapter 3. Number 1 says, according to taxifarefinder.com, a cab ride from the airport in Las Vegas will cost you an initial charge of $5.10 plus $2.60 per mile. Can you pick out the rate in this statement? And then once we do, let's write it as a fraction. One word that will clue you in that there may be a rate being talked about is this word per. When they tell us it's $2.60 per mile, that's our rate. Now you may say, well, what do they mean write it as a fraction? Do they want me to convert that decimal into a fraction? No, they just want you to write that as $2.60 per mile means for every 1 mile. The one is optional. You could just put $2.60 over miles. All right, let's move to page 276 and use this rate. Number 2, you can see they've started a table for us. They tell us that if I go 0 miles, I'm going to be charged $5.10. That's what that paragraph told us, that there's an initial fee of $5.10. And then for each mile, I'm adding $2.60 onto that. So the way they got $7.70 for 1 mile was they took $5.10 plus $2.60. Then they added $2.60 again. I'm going to get out my calculator to help me here. So we left off at 10:30. And it was on and it turned off. There we go. So let's type in the $10.30 and add $2.60 for an additional mile. That tells me it's $12.90, so that's what I'm going to write in the box. I can get it on my calculator. There we go. You can continue to use your calculator to add $2.60. Take $12.90 plus $2.60. Your calculator is going to give you $15.50. And then add $2.60 one more time, and you're going to get $18.10. Now they ask us to graph it. So we learned back in chapter 1.5 about how to plot points. That's all we're going to do here. So 0, 5, 10 is over 0, and then up 5, 10, which should be right roughly between 4 and 6. Go over to 1 and up to $7.70. That's pretty close to $8. 2 and 10.30 is over 2, and then up just a little bit above 10. 3 and 12.90 is almost a 13, so right between 12 and 14. It's a little high. 4 miles cost $15.50. That's almost a 16. And 5 miles cost just over $18. So we're using, let's make my pencil skinnier again. We're using the distance for the X and the cost for the Y. Notice this graph has my labels, has my titles, everything a good graph needs. What type of growth is this? Back in chapter 1, we talked about two different types of growth. We talked about linear and exponential. What does it look like this one forms? I think it looks pretty much like a line. So we will call this linear growth. Number 4 asks us to connect the dots. We want to connect the points so that we can see the shape a little better. So back up here where we drew it, we're going to connect these, and I'm terrible at drawing straight lines, but I'll do my best. Now you'll notice that I put an arrow on the right end of this graph, and they actually talk about that in number 4 as well. I can go more than 5 miles, so I want to continue that line going on forever to the right to allow myself to go more miles. I don't need an arrow to the left because I'm never going to have negative distance, and that's what going to the left would be. So should it have an arrow on the left side? No. Should it have an arrow on the right side? Yes, because my miles can continue to increase. They're going to teach us a few more things about this graph. They're going to talk about the y-intercept and the x-intercept. This is something that we'll work with all of chapter 3, so it's not going to go away. Y-intercept is defined as being where it crosses the y-axis. So this is your y-axis. Where does my line cross the y-axis? That's the distance 0, and we know from the graph or from the table that happens at $5.10. So the y-intercept is 0 miles and $5.10. And remember, back to our section on graphing, ordered pairs have parentheses around them with a comma in the middle. Now they ask us about an x-intercept. X-intercept is defined as where the graph crosses the x-axis. So that's going to be along here. And you'll notice that this graph does not cross the x-axis. It is not going to, because that would have to be somewhere on negative distance, so there is no x-intercept. We'll say none. Moving on to the next page, we're finally going to get into that idea of slope and rate of change. They are blowing up a part of our graph. The part of the graph they're blowing up here is at $2, it costs $10.30, and at $5, it costs $18.10. And they're going to walk us through some pretty cool steps. So the first thing they want you to do is subtract the y-coordinates. So that's the second coordinate in each one. So we're going to take 1810 minus 1030. And let's see what we get. $18.10 minus $10.30. I get $7.80. And then they do ask me to label that up on the triangle for the vertical change. We're going to do the same thing with the x-coordinates now. We're going to subtract in the same order. So since I did 1810 first, I have to do the 5 first. I'm going to take 5 minus 2, which gives me 3. I can actually do that one with my calculator. Label it where it goes on the triangle. Then number 8 is where we bring it all together. It says take that vertical change divided by the horizontal change. So let's put our 3 on the bottom. And we'll stay color coordinated. We'll put our $7.80 on the top. And then we're going to get the calculator out to actually divide that out. So we're going to take that $7.80 divided by 3, and you're going to see a number that you recognize. You'll be sick of this number soon. 2.6. So that is the $2.60. If you were to leave off the 0, that's not a problem. We're just used to it with money. $2.60 per mile, which was what they told us in the beginning. That was the initial cost per mile. So that's one way to do it. Towards the bottom of page 277, they talk about the word equivalent. It's an important word in math, and we use it a lot in this course. Equivalent means they have the same value or are interchangeable even if they look different. You saw this back when we did dimensional analysis. So we talked about things being equivalent. So $7.80 for 3 miles is equivalent to $2.60 per 1 mile. When we write it over 1, that's called a unit rate. They're much easier to read. The denominator is 1. Unit rates make so much more sense to us. For example, if you went on the highway tomorrow and instead of saying 65 miles per hour, it said 130 miles in 2 hours, there might be some confused people out there. So unit rates are definitely more applicable. It's also awesome if you're trying to figure out which is the best price of an item at the grocery store. Some stores will actually print it on their tags, their price tags. Number 9 asks us to pick 2 more points that we didn't use. So let's see, we know that 1 mile costs $7.70, and I'm just looking back at the table we filled in number 2. We know that 4 miles costs $15.50. And they want us to do the same thing. They want us to go through and subtract those y values, or the vertical change. So 1550 minus 770. So 1550 minus 770. Get my calculator out for this. Let's clear it. Sometimes there's too much stuff on there. $15.50 minus $7.70 gives me a difference of $7.80. Then let's subtract the x values in the same order. So 4 minus 1. And then let's finally divide the top number divided by the bottom number, and let's see what we get. 7.8 divided by 3. There's that number we keep seeing. Like I said, you're going to be really sick of that number by the time we're done. It would not matter which 2 points you used. It will always be that $2.60. Moving to page 278, we're still talking about the taxi for a little bit more here. They want to know how much would 4 miles add to the cost of the taxi ride. Well, we know that the taxi ride is $2.60 per mile. And I can multiply that by 4 to figure out how much it will add. Again, I'm going to use my calculator. 2.60 times 4. It's going to increase my cost by $10.40. Does that matter if we're going from 1 to 5 miles or 20 to 24 miles? No, it does not matter if you where you're increasing those 4 miles. 4 miles is 4 miles. Doesn't matter if I'm going from 100 to 104. Obviously, my total price would be higher, but it's still going to increase by $10.40 for that extra 4 miles. Now, 11 is going to drive home this point. The thing that makes a line is the fact that the slope never changes. We've seen that $2.60 many, many times now. We now know that the slope of a line describes the rate at which the y coordinates change compared to the x coordinate. Rise over run. You may have learned it that way. Vertical change over horizontal change. Based on this, how can you decide if the relationship between the two quantities might be modeled by a straight line, besides just visually looking at it? The easiest thing to do would be just calculate the slope. So finds the slope several times. Use different ordered pairs to find the slope. And if it's constant, it's a line. So constant equals a line. So now we've got a way to at least informally verify that something is a line. Number 12 wants me to estimate the distance of a $16 cab ride. We can use the table or graph, so I'm going to scroll back up to the table and the graph because they're right next to each other and figure out about where $16 would be. Oops, one more scroll. I didn't realize we were back that far. So $16 on the table is somewhere in here. It's between $15.50 and $18.10, closer to $15.50, so a little over 4 miles. If you want to do it based on the graph, $16 is here. And we get the same sort of idea. So a little more than 4 miles would be the answer that is best for this. We will work our way towards learning how to solve those in this chapter, not in this section. So we'll say a little more than 4 miles. So we haven't really actually called this slope in the book yet. Now we're going to. Purple boxes are always important information. This is the formula for slope. This is what you've already been doing. When we subtracted those y values, subtracted the x values, divide them out, that is the slope formula. Rise over run, vertical change over horizontal change. It's definitely a formula you need to know. Page 279 has a worked out example for us. I love that this is in here. This is new to this new edition. They just gave us 2 points and asked us to find the slope. So I'll color coordinate for you because I do think that helps. It helps me at least. First of all, they take and subtract the y values. They did -2, -4. That's where this is coming from. Then they subtract the x values in the same order. That's why they did 4 minus 1 and not 1 minus 4. You have to do it in the same order. Whatever y value you picked first on top, you have to pick that x value first on the bottom. Then they do the arithmetic. You can use your calculator for that. -2 minus 4 is -6. 4 minus 1 is 3. Slope is -2. And then they ask you to find the intercepts. Let's see where they have it down here. Which do they find first? They find the x-intercept first. So the x-intercept is right here. So you could use the graph to find that. That's, oh, they did y-intercept first, but this is the x-intercept. That's 3, 0. It's where it crosses the x-axis. Let's find the y-intercept. Y-intercept is where it crosses the y-axis. It's over 0, up 6. So all those points are looking for is where does it cross the axis? Page 280. I believe this is the last page, yeah, before we get into the group stuff. Another worked out example, but again, I want to walk through it with you, make sure we understand what they're doing here. They gave us a table and they gave us a graph, which is awesome. I like having both. They ask you to find the y-intercept first. That's this point right here. It's also on your table always, if the first number is 0, the second number is your y-intercept. So they have that answer down here. The y-intercept is 0, 15,000. And what I love about this class is in most cases, the numbers mean something. This 15,000 is the starting value of the car. That's how much you paid for the car. Then they ask you to find the slope. You're going to do it the same way we've been doing, using any two ordered pairs. I'll just start with the top two, 13,000 minus 15,000, and then do the x values, 1 minus 0. So that's where these numbers are coming from. And it's negative this time. It's negative 2,000. That means the car is decreasing in value. It's called depreciation. Estimate the value of the car after 42 months. Well, 42 months is 3.5 years. I have to think through that first. 3.5 years can be found between 3 and 4, so it's right here somewhere. What would be directly between 9,000 and 8,000? Or just gave you the answer, 9,000 and 7,000. 8,000, so 8,000 is a good estimate. And then they ask, when did the car reach $6,000? Do that one in pink. 6,000 would have happened somewhere between 7,000 and 5,000. What's right between 4 and 5? Well, about 4.5 years. So you are going to work in your groups. You're going to learn about snow cones. You're going to be sick of snow cones by the end of the semester, but that's okay. And you're going to work with more of this finding slope and finding rate of change with snow cones. I hope you have a wonderful time and a wonderful day, and I will see you next time.